Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface. In the previous lecture, we saw the use of the auto keyword in C++, and we said that it's a nice type inference that the C++ includes from C++ 11, I believe. And then we created a person class which had two fields, a string name and int age. It has a constructor that creates the object, and then we override the toString method to print the information of the object. And then we created a new class, test auto. We are loading the dynamic library. We created a static native method, create person. So we send the Java string and Java integer to C++, and there we create a person and send it back, right? So we create a person object and send it back. And then so the implementation in C++, we cache the class ID, the jclass, and then the constructor ID, and constructor is just a special method. The name is init, and then we create the person, and know that I'm using auto in all places, and then we return the object. So the type is already inferred. This person class is jclass, and then this constructor ID is jmethod ID, and this person is jobject, as we expect. All right, but then once we ran the Java, so we created a object bob21 and did the sysout on the bob and the person, and it works fine. All right, so let's call this bob. And then once we created the second person, let's call it James, we saw that it's the JVM crashed. So as you see, the first person gets created correctly and successfully, but for the second person, it crashed the JVM. And if I comment out the first object Bob and try to just create James, it appears to work fine. Yes. So the problem is that we create one person successfully, but the second person crashes the JVM, and the question is why. So I guess it's a good thing to look at the actual crash log to see what's going on. So we have some threads. These are the registers of the CPU, and then we have the top of a stack. And note that one thing that you need to check for when you look at the crash log is the type of the configuration of your VM virtual machine. Mine is using the compressed OOPS, which means that even though the addresses or the pointers of 64-bit, it just uses 32-bit by default. And the JVM has a flag, a parameter, or VM arguments, so we can manually turn this compressed OOPS on and off. All right. So the idea here is that even though the address is 64-bit, we can use only the 32-bit of it, because that saves memory and we can still work fine. If the heap size that we allocate to our JVM is less than, I believe, 32 gigabyte, it's always a good idea to use the compressed OOPS, right, to save on the pointers and the references and the addresses. So all the addresses on a 64-bit machine are long integer, which means there are 8 bytes. And then when we use compressed OOPS, we only use 4 bytes. All right, as the pointers. Now if you go back and look at the what's going on, as you can see, we start fine, and then we are in the main method, and then we invoke test1. And this has the annotation J, which means this is Java interpreter. C is the native code, and then V is the VM code, virtual machine code. And then so the Java is creating the person, calls this, and then jclass jmethod ID, we go into the C, and then something goes wrong when we try to create a person, right? So the question is, what is going on? So if you play around with this, and I left this as an exercise to you to try to figure out what's going on. So if I remove the static from the jclass, the person class, and then build this again, and then go back to Java and copy paste the dynamic library, and then run this code. Let's see if this works. Yes, now it works. So we can put a static on this constructor ID, this method ID, but it appears that when we put the static on this person class, which is the jclass identifier, the meta information, the JVM cannot create the second object. And the question is, why is this happening? So if I copy and paste the dynamic library again, and then try to create the first object, which works fine, but the second object, JVM cannot do that, and it crashes. So some sort of exception happens, and then it causes the JVM to crash, right? So the question is, why is it when I remove this static, I don't cache this jclass, the JVM has no problem with allocating the second object? And the answer is, so let's try to copy and paste this dynamic library again and try it one more time. So right now there is no static on this jclass, there is a static on this constructor ID. And if I run this, hopefully we see the two objects work fine. And the answer here is that when we create an object, an instance of an object, that object gets its own class metadata. So it's basically in Java, we can have public static void test2. Let's create this and quickly look at this. Test2. So I can have two different class basically metadata. One is, so class, let's call this class 1, associated with the class itself. All right, and this is a parameterized type, and this is parameterized over the person class because this is associated with the class. But then we can also have an instance of the person. Bob is new person, let's call him Bob, and age 21. But this instance, when we create this instance, it also gets its own class object. So class or class class 2 is bob.getClass. So this returns a class object that is associated with the instance, and this is different from this type of class that is associated with the class. First of all, this is not actually parameterized on the person. So if I say this is a class of the person parameter, the compiler gives me an error and says, okay, this is not correct. This is the type of this class is not actually person. And this is basically, if we actually look at what is the actual type, let's see what the compiler can help us with. It's anything that extends person, and these two are basically different entities. So what happens in C++ for us is that when we create the first person, get the jclass, and then we create the object, now that jclass that we got is associated with this instance, and we cannot use it to create another instance, because once we put it label it as a static, that is always fixed. So the problem that JVM has is it creates an instance, and that jclass is now associated with this instance, and then next time that we come back into this object, into this function, the jclass pointer is still the same, pointing to that instance, to the previous instance. Therefore it cannot create a new instance because it has to allocate new memory, and it should be a new jclass pointer. All right, so when we're creating objects, don't cache the jclass, because once you create a new object and then associate a jclass to it, then you cannot instantiate more, because that jclass pointer is now pointing to the actual instance of the object. Just like here, that we can have a class parameterized on the class, a class that is parameterized on the instance, and these two are different. So I cannot basically let's say class 1 is bob.getClass. So this is a compiler error, and that's why the JVM is crashing in this case in C++ when it's trying to create the second object, because we cannot, there's a type mismatch here, cannot convert from a class that extends a person to a class that is parameterized on the person itself. All right, so this is the difference. We still have the same jclass object. There is no different types for a jclass that is associated with the instance and a jclass that is associated with the class itself. So we still use JVM find class. But once we instantiate an object with the new object, that jclass is now associated with the instance that we just created, and we cannot use a static then on the jclass, because then it just messes up the other basically instances that we create. And it's exactly the same situation here, again, if I cannot assign this bob.get class, which is a class that is associated with the instance, to a class that is associated with the person class itself. So I cannot say class 1 is bob.get class. This is a compiler error, and any compiler error in C++ crashes the JVM. That's why we're not able to create the second instance. So this is a compiler error. This is one of the subtleties about the reflection API, and how this class is associated with an instance or the class itself, right? So here we have to remove the static on the jclass because we are instantiating objects, and that jclass gets associated with the instance. All right, so different instances must have different jclasses, and that's why we cannot put a static on this. All right, so let me delete these log files, and then now we can compile this again. And again, the good thing about this auto here is that we don't really need to worry about what is the actual type. We just only need to know, okay, I need a meta information, and then the constructor ID because it's a method, and then I need to create a new object based on this constructor and the jclass, and then returning. And as you can see, the types are already inferred. This person class is automatically jclass, constructor ID jmethod ID, and person object is jobject. All right, so again, when you are creating new objects, don't cache the jclass because that gets associated with the instance that we are creating. So each instance should get its own jclass. All right, so if I compiles fine. Let's copy and paste to Java again, and then run the code, test 1. And now you will see that it can create both objects, no problem. Each one gets its own jclass. So if I create a new object again, that's fine. So Tom, and then 41, and then Tom. So we can create as many classes as we want, as many objects as we want from the person class. That's no problem. The key here is that in C++ we should not put a static in front of this jclass, because each instance, when we use this new object, each instance must get its own jclass. That's because, again, we cannot associate the class object of that is associated with the class with a class object that is associated with an instance of a class. Okay, so I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.